In today's Python statistics video, we're going to be taking a look at the single sample sign test. We're going to go over a little bit of the background information behind this test, then go over a manual calculation, and then I'll show you how we can use a shortcut within Python with the help of SciPy. But before we jump into that code, let's go over a little bit more information about this test. All right, so info on the sign test, single sample. So you can use a sign test for a single sample or matched pairs. This video focuses on single sample. If you want to watch matched pairs, I have another video for that, so check that out. Now, this is a non-parametric statistical test used to determine if the median of a single sample is different from a specified median. It's ideal for ordinal data or data that may not meet the assumptions of normality. If it does fit normality, right, you want to use typically your single sample t-test. No reason to use the sign test. Otherwise, let's go with the sign test. Our null hypothesis will say the median of the sample is equal to the hypothesized value. There's no difference. Whereas our alternative hypothesis, the median of the sample is not equal to the hypothesized value. There is going to be a difference. So the steps first is find the null and alternative hypothesis alpha value. And then you want to check the normality with Shapiro-Wilk. In this video, we're going to make some assumptions, right, that these aren't normal distributions. Also show you Shapiro-Wilk a little bit later. And if you're not familiar with Shapiro-Wilk, no worries. I do have a video on that, which I recommend you watch after this because it is pretty useful. Anyways, for each observation in our sample, what we want to do is find the difference between observed value and the hypothesized median. We want to ignore any pairs at the very end where the difference is exactly 0, as they provide no information about the direction of change. And then you want to count the number of positive differences as well as the number of negative differences. The smaller of these two different counts is going to be our test statistic. And then lastly, we're going to do a binomial test to find our p-value. So let's go through an example looking at Shohei Ohtani rookie card values. We're going to use the hypothesized median value of $500. We'll say alpha 0.05. Assumption is this is not normally distributed. I didn't actually check these numbers with Shapiro, but we'll just assume that, right? And these are things: 650, 470, 520, 480, 536, 450, 560, 480, and 510. The null hypothesis, the median Ohtani value is 500. Alternative, the median Ohtani rookie card value is not equal to 500. So we've heard before and after, right? And one thing I'll say is it doesn't matter how you subtract it, right? You could have the hypothesized value minus the before value or the other way around. Because we're just looking for signs, right? And we're going to find the minimum of these signs. So order does not matter. Just make sure you're consistent across the board. Regardless, by doing this, right, we get 6 positive values. We have 150, 20, 30, 100, 60, and then 10. And then we have 4 negative values, right? Negative 30, negative 20, negative 50, and negative 20. No zeros, so nothing to remove over here. Our test statistic, right, minimum between 6 and 4 is going to be 4. Then we take a look at the binomial distribution. We have n equals 10 because we have 6 positive and 4 negative. We add these up together. Again, if 0, we don't count that towards, right? A p-value of 0.5. And at the very end, we get a p-value of 0.753, which is way greater than 0.05. So we fail to reject the null hypothesis. The result of the sign test indicates that there is no significant difference between the median price of Ohtani rookie cards and the hypothesized value of $500. So with this background out of the way, I think we're ready to start coding. So grab your notebook and let's start writing some Python. All right, so let's get started. We're going to say it's from SciPy.stats import binomial test and also Shapiro. And then import NumPy as NP. And then after that, we're going to just set our alpha value for the video. So alpha equals 0.05. And we're good for example 1. So we're going to emulate that first example we did in the slides first, and then we'll go over some other examples. So we're setting our median to 500, right? That was the value of the Ohtani cards. And now we pass in our values. So these are the values: 650, 470, 520, 480, 530, 600, 450, 560, 480, and 510. We have those over here. Then what we're going to do is the differences. So we're going to say differences equals median minus values, right? And then let's print out these differences just so you can see what these look like over here, right? 150, 30, negative 20, 20, negative 30, negative 150, negative 60, 20, negative 10. Again, doesn't matter. You could have values minus median, median minus values. We're going to get the same answer at the very end, right? So then what we want to do is have our positive diffs. So positive diffs equals np.sum. And then we'll put in here differences, which is greater than 0. Then we're going to have our negative, and it's just going to be flipped, right? So put negative like that. Right, run both of those. Okay. Then up next, we need to find our test statistic. So test statistic equals min, and then pass in positive and negative. So positive, then we have our negative like that. So both those are passed in over here. And then we can just print out the min. So print this out, and we should get 4, but let's double check. And we do get 4. Awesome. So now let's find our n value. So n is going to be equal to positive plus negative. Remember, we're ignoring zeros, so that's why we just add these together. Okay, n is going to be 10. So now what we can do is find our results. So we'll say results equals binomial test, then pass in our test statistic first. So we have our test statistic, then we pass in n, then we pass in p equals 0.5, and then we say this is a two-sided test, so alternative equals two-sided. Right, and then what we're going to do is find our p-value. So to get our p-value, you go p-value equals and results dot p-value like that. And then we can print out our p-value. So print out our p-value. And our p-value is going to be 0.7539. And then I always like doing an if-else statement. Right. So if p-value is less than alpha, the median of the sample is not equal to the hypothesized value, else the median of the sample is equal to hypothesized value, no difference. And the median of the sample is equal to hypothesized value, no difference, because our p-value is much larger than 0.05. Okay. Hopefully this makes sense, right? So find the differences between your values in the median, positive, negative, use the min test statistic, then find the n, which is positive plus negative. Then you just run a binomial test, and yeah, you get your p-value from there. All right, so let's take a look at example 2. We're going to change up a few things here. So first, we're going to look at ordinal data. Then we're also going to include some zeros, and then we're going to run our Shapiro. And then also we're going to do a one-tail test with greater than, completely different example than our first one. So what I want to do first is pass in our data. Now, I've already mapped our ordinal data, right? So let's just say our ratings are 1 through 5. Initially, it would be A, B, C, D, F, right? So there you go on that side of things. And then what I want to do next is we'll set up our median. So we'll say hypothesized median equals 3 in this instance. And the first thing we want to do is we want to run our Shapiro test, because I want to make sure that this is non-normal distribution. That's why we're running our sign test, right? So we'll say Shapiro stats. We don't care about that one. We would care about our p-value. So Shapiro p-value like that. And then what's going to be equal to Shapiro? And then just pass in our ratings over here. And as I mentioned in the slides, I have a full Shapiro video if you want to learn a lot more about it. I'm going fast through it because this isn't a video on it. But you can see our p-value is going to be less than 0.05. So we reject the null hypothesis, right? We go with that this is a non-normal distribution. So we're good to go with the sign test, right? So we'll continue moving forward. And what we want to do now is we want to find our differences. So like before, differences, just make sure you're consistent on how you calculate this. Ratings minus hypothesized mean. And This also does matter when you're going with specific tail directions. So that is going to be your one case, right? If you're just looking for the difference, it doesn't matter as much, but when you're going for tail direction, it does. So you have ratings minus hypothesized median, and then we'll say print out our differences just to show you that we're going to have zeros here, right? 1, 2, yeah, 2 zeros. Cool. And what we're going to do next is we're going to find our positive and negative counts. So how we do that is the same as above, right? Positive count, if I can spell it correctly, right? Positive count equals np.sum, so differences 0, and then we'll do our negative count also, and just flip the sign, right? Negative count. Great. Then let's get our test statistic. So test statistic equals min, pass in positive and negative. Whoops. Positive and negative. And then we can print this out. So print our test statistic. And our test statistic in this case is going to be 2. So now what we can do is we can run our binomial test. So we'll just have results equals binomial test there. First pass in our test statistic. Then we'll say n equals n, p equals 0.5. And then we're going to do alternative. Fix this over here. There's 3 different alternatives that you could run in the binomial test, right? I already showed you two-sided, which was our first example, which looks at either side. Then you also have your greater than, or I should say greater, and then you also have less. In this example, we're going to go with greater. So pass in greater like that. All right. And now we want to get our p-value. So we'll say p-value equals, and we'll say results dot p-value like that. And print out our p-value. Great. And our p-value is close to 1. So we fail to reject our null hypothesis in this case. As a bonus, what I wanted to do for you guys is also show you how we can calculate this really quick with stats models. I haven't used stats models in the stats series here on the channel. I've been using SciPy, but you know, if you don't want to have these extra steps, you can make this pretty easy. So what I'm going to just do really quick is we're going to go over here and grab our first example, because that's what we've been using a lot for the video. And this will be for our example 3 with stats models. So we'll say example 3 stats model over here. Okay. We have our median of 500. And then I just want to grab this just to show you. You can really make this fast again. So median, and then we have our values. And then let's import in stats models. So import stats models, and from stats models stats descriptive stats, import in our sign test, import sign tests. Great. And then literally all you have to do is this one line of code. Sign test, pass in our median, and pass in our values. And you'll see over here, right, there's our 7539. Yeah, one line of code. Unfortunately, SciPy, you have to have a little bit more, but I've been using SciPy for the whole series, so I felt like I could show you this way, but it's honestly not too bad. But if you want to have like a super shortcut, use stats models. And yeah, I mean, that's essentially the video on the sign test for your single sample. Well, that's it for the single sample sign test video. Hope you guys enjoyed it and found some value from it. And if you did, make sure to subscribe to the channel. We're uploading a few videos every single week focused on data science. Now, if you want to learn even more about statistics, I have other videos linked down below in the description and a playlist right over here. So check those out.